In this set of lectures, we will talk about time value of money. This is a very long reading with several sections. In section 2, we'll talk about the different interpretations of interest rates. And then the next few sections deal with the future value of money. In other words, if we have some money now, what is the equivalent value of this money in the future? Or at times, we might have a cash flow stream and we might want to calculate what is the value of this cash flow stream at some point in the future. The term for this concept is future value. Then the next few sections deal with present value. Here we deal with cash flow that's happening in the future, and we want to understand what's the value of this future cash flow at an earlier point in time. Section 11 deals with solving for interest rates, growth rates, and number of periods. You will notice that these sections are fairly mathematical and there are multiple variables involved. There might be a situation where you are given all the variables except for one, and then you will have to solve for that unknown variable. Then in section 12, we'll solve for the size of annuity payments, and section 13 deals with present value and future value equivalence, and here we also talk about the additivity principle. A brief introduction. If you have $100 today versus an option to receive $100 after 3 years, so this is time 0, this is at the end of 3 years, what would you prefer? Obviously, you would prefer $100 today. Even though we have $100 in both cases, you prefer $100 today. This means that there has to be some value associated with time, because you are putting more value on the $100 that you are getting today relative to the $100 at a later point in time. The money today, or the value today, is called the present value. At times, this could be an investment which you make at time 0. The value at a future point in time is called the future value. Let us say that you are indifferent between $100 today versus $110 after 1 year. This $110 is then referred to as a future value at the end of year 1. The relationship or the link between present value and future value is established through an interest rate. And what we are going to do in this reading is essentially talk about these concepts: present value, future value, and the way we link these two concepts using interest rates. The central theme is interest rates, so let's talk about the different interpretations of interest rates. Interest rates can be interpreted as, number 1, a required rate of return, or a discount rate, or a opportunity cost. Say you lend $900 today and receive $990 after 1 year. So if we put this on a timeline, time 0, you lend 900, so let's put a minus sign to indicate money out, and then after 1 year you get 990 back. The fact that you are willing to do this, you are willing to give $900 today on the condition that you get 990 after 1 year, means that to engage in this transaction you are requiring a return of 10%. I'm sure you can calculate this, given that you are lending 900 today or investing 900 today and getting 990 after 1 year, that interest rate is 10%. And the required rate of return interpretation is simply saying that you require a return of 10% to engage in this overall transaction. So that is the required rate of return interpretation. Discount rate is also straightforward, and we'll cover it briefly here and in a lot more detail later. But if you think of the money that you are getting after 1 year, which is 990, you can discount 990 at 10% to get the present value of 900, and therefore the 10% can also be thought of as a discount rate. And finally, opportunity cost. Let's say that you had taken the $900 and spent it on something else. What you have then done is you have foregone the 10% return that you might have received. And if you remember, the concept of opportunity cost is the cost of what you forego. In this particular case, what you have foregone is the 10% return. Therefore, 10% is also be thought of as a opportunity cost. We shift gears a little bit now and look at interest rates from an investor perspective. As an investor, we can think of interest rate as a sum of multiple components. The first component is the real risk-free interest rate. This is the rate that you get on a security that has no risk and is extremely liquid. And we make an assumption here that there is no inflation. We can then add on an inflation premium. Inflation premium is the expected annual inflation in the upcoming period. We can also then add the default risk premium. This is the additional premium that an investor requires because of the risk of default. And you can understand this through a simple example. Let's say that you lend some money to person A and also lend some money to person B. To both these people, you are lending $100 initially. B has a high risk of default, so you are worried that B might not pay. Then you might demand a higher return from B because of that risk of default. That additional return that you will demand from B because of the risk of default is called the default risk premium. Next, we have liquidity premium. This is the premium an investor demands because of the lack of liquidity of an investment. Here again, think of two investments, C and D, which are similar in all regards. The only difference is that investment C is liquid, extremely liquid, whereas investment D is not that liquid. Clearly, as an investor, we will demand a higher return on D because it is not liquid. That additional return that we demand is called the liquidity premium. And finally, we have maturity premium. The idea being that if you have two securities again, let's say E and F, E has a maturity of 1 year and F has a maturity of, let's say, 4 years. Because F has a longer maturity, it has a higher risk in terms of the price of F being more sensitive to changes in interest rate. And this is a concept that you will understand better when we do fixed income securities. But for now, you can just take it as a given that F has higher risk because of the longer maturity. And obviously, an investor will demand some compensation for that higher level of risk. So the sum of the real risk-free rate and the inflation premium is often referred to as the risk-free rate or the nominal risk-free rate. So if our real risk-free rate is 3% and the inflation premium is 2%, then the nominal risk-free rate is 5%. If you hear the term risk-free rate, then the assumption is that we are talking about the nominal risk-free rate. Let's look at a practice question. Jill Smith wishes to compute the required rate of return. Which of the following premiums is she least likely to include? The correct answer is C, nominal premium. And we say that because while this sounds like a nice term, but it is clearly not included in the list of premiums that you saw on the previous slide. It is possible that you'll see a question like this on the exam. So make sure that you know all the premiums really well. Next question. The correct answer is C. The required rate of return is the minimum rate of return. So A and B are correct options. C is not correct because of this. This is a mistake, and since we are looking for least likely true, C is the choice. Another practice question. Say you have 5 different investments and we have the maturities for each investment, the liquidity, default risk, and a interest rate for each investment. Why is there a difference between the interest rate on investment A and investment B? They have the same maturity, they have the same default risk, but interest rates are different. And the answer is because of the difference in liquidity. Does it make sense that the return on B is higher? The answer is yes, because B has lower liquidity, and therefore investors will demand a higher return for investing in B relative to investing in A. That higher return happens to be 0.5%. So in our simplistic example here, 0.5% is the liquidity premium. Next question is estimate the default risk premium. And before you go on, try to solve this on your own. If you look at investments D and E, notice that they are both 3-year investments. They have a different liquidity in the sense that D is high liquidity, E is low liquidity, default risk is different, and interest rates are different. What we need to do is make the liquidity the same. Let's say that D for some reason goes from high liquidity to low liquidity. Will that change the interest rate? The answer is yes. If the liquidity becomes low, then investors will require a higher return. And we've already determined that the liquidity premium is 0.5%. So we add 0.5% and we have 3.5% as our return. Then what we can do is the following. If we have this newer version of D, let's call it D bar or D complement. So this has a low liquidity versus E, which also has low liquidity. Default risk here is high. The difference between this new version of D, which is the low liquidity version, and E is 1.5%. The difference between the new version of D and E is 0.5%. This means that the default risk premium is equal to 0.5%. And finally, can you calculate the upper and lower limits for the interest rate on investment C? Notice that between B and C, the only difference is that C has a longer maturity, which means that the interest rate on C must be greater than B. So we can say that R has to be greater than the return on B, which is 2.5%. So R has to be greater than 2.5. And if you look at the low liquidity version of D, that has a return of 3.5%. Other than that, it is similar to C because liquidity is the same, default risk is the same. So maturity is less. So maturity for investment C is less than the maturity for investment D. That means that R has to be less than 3.5. So the range for R has to be between 2.5 and 3.5.